You're sitting in your room, lights off, screen glowing. It's 2:47 in the morning. The rest of the world is asleep, and somewhere on the other side of the planet, in a city you've never visited, someone just did something extraordinary. They broke into a system. Not with force, not with an army, not with a weapon, just knowledge. No noise, no trace, no drama. Just a person, a machine, and an understanding of systems that most human beings will never come close to. And the most unsettling part? That person wasn't born different from you. They didn't have a special brain. They didn't have access to secret schools, secret teachers, secret knowledge buried behind locked doors. They just knew something specific, something learnable. Something that you, right now watching this, could begin to understand. That's what this video is about. Not the mythology of hacking, not the Hollywood version with dramatic music and spinning 3D graphics. The real thing. The actual path, the actual mindset, the actual timeline, the actual truth about what it takes to enter one of the most powerful, most misunderstood, most in-demand skill sets that exists in the modern world. I am not going to waste your time. I am going to give you something real. Stay until the end, because the last thing I say might be the most important thing you hear all year. Part 1. What a hacker really is. Let's start by destroying a lie. The word hacker has been so thoroughly destroyed by movies, TV shows, and news headlines that most people have no idea what it actually means. When most people hear hacker, they imagine a person in a dark hoodie, probably in their late teens, surrounded by energy drinks, typing furiously on 6 different keyboards while green scrolling text fills every screen and some dramatic countdown clock ticks towards 0. That image is a fantasy. It was created by people who have never touched a terminal in their lives. Here is what a real hacker actually is. A real hacker is a problem solver, someone who looks at a system, any system, and asks, where does this break? That's it. That is the entire foundation of hacking philosophy in a single sentence. Now, what is a system? Everything is a system. The app on your phone is a system. The website you logged into this morning is a system. The Wi-Fi network you're connected to right now is a system. The login page, the checkout process, the API that connects 2 pieces of software, all of it. Every single layer of the digital world you inhabit is a system built by humans. And humans make mistakes. Humans forget edge cases. Humans take shortcuts when they're under pressure to ship a product. Humans make assumptions about how users will behave and leave gaps where the unexpected can slip through. A hacker's job, especially an ethical one, is to find those gaps before someone dangerous does. The hacker is not the villain of this story. In most cases, in the real professional world, the hacker is the guardian. They are paid to think like an attacker so that real attackers never get in. And the companies that understand this, every major bank, every hospital network, every government agency, every tech giant, they don't just tolerate hackers, they employ them, they pay them extraordinarily well, because the alternative is far more expensive. In 2023, the average cost of a single data breach exceeded $4 million. In 2024, that number climbed further. By 2025, entire industries were restructuring their security budgets because the digital threat landscape had become too complex, too fast-moving, too relentless to ignore. And somewhere in the middle of all this chaos, there's a massive, growing, urgent need for people who can think like hackers. People exactly like you could become. Part 2. The truth nobody tells you. Now, I need to tell you something uncomfortable, because the internet is full of content about hacking, YouTube videos, online courses, forums, Discord servers, and almost all of it gets one crucial thing wrong. They make it look easy. They show you a tool that automatically finds vulnerabilities. They show you a script that does the hacking for you. They give you a list of commands to memorize, and they make it feel like knowledge. You do not start hacking by hacking. You start hacking by understanding. This is the most important sentence in this entire video. Read it again, because here's what happens to the 95% of beginners who skip this step. They download a tool, the tool does something, they don't know what it did, they can't reproduce it manually, they can't explain what vulnerability was exploited or why it worked. They are what the security community calls a script kiddie. And that term is not an insult, it's a description of a stage. Most people who enter this field start there. The question is whether you stay there. The ones who stay there never build real careers. They never earn serious money. They never develop the deep intuition that makes someone genuinely dangerous in a white hat way. The ones who move beyond it, who actually invest in understanding, they are the ones who end up working at Google, at CrowdStrike, at national intelligence agencies. They are the ones earning 6 figures, finding vulnerabilities in multi-billion-dollar software products, and getting paid handsomely to report them responsibly. Here is the real truth about hacking. It is not a shortcut to power. It is a long game of compounding knowledge. Every concept you genuinely understand builds on the next. Every vulnerability you truly learn opens up 3 more. The knowledge tree is massive, but once you start building it correctly, it grows in ways that feel almost magical. Hacking is not about breaking things, it is about understanding things so deeply that you can see exactly how and where they break, and then deciding what to do with that knowledge. So yes, this is hard. Yes, it takes time. Yes, there will be periods of confusion and frustration that make you question whether you should continue. But I promise you this, the skill on the other side of that discomfort is unlike almost anything else you can learn in a world desperately needing the people who have it. Part 3, the foundation. Everything starts here. Before we talk about hacking a single thing, we need to talk about foundations. I know, that sounds boring. Bear with me, because this section might be the most practically valuable thing I say in this entire video. There are 4 pillars that support everything in cybersecurity. Without them, you are building on sand. With them, you have something solid enough to construct a career on. The 4 pillars are programming, networking, operating systems, security fundamentals. Let me take each one seriously. Part 4. Programming, thinking in code. Programming is the first pillar, and I don't say that lightly. Almost every beginner asks, do I really need to learn to code to be a hacker? And the honest answer is, you don't need to be a software engineer, but you absolutely must understand how code thinks. Here is why. Every vulnerability, every single one, exists because of code. A SQL injection attack works because a developer wrote code that didn't properly sanitize user input. A buffer overflow attack works because a program allocated memory in a way that didn't account for unexpected input size. Cross-site scripting exists because output wasn't properly escaped. If you don't understand code, you can exploit vulnerabilities mechanically, but you will never understand why they exist, and that why is everything. Start with Python. Not because Python is the best language in some abstract sense, but because Python is designed for human readability. It teaches logic without drowning you in syntax. It is the most widely used language in security tooling. Most professional penetration testing frameworks, automation scripts, and exploit tools are written in Python. What specifically do you need to learn? Variables and data types. Understanding that information exists in different forms, strings, integers, booleans, lists, dictionaries, is the beginning of understanding how programs store and process data, and data processing is where almost every vulnerability lives. Loops and conditionals. Loops are how programs repeat tasks. Conditionals are how programs make decisions. When you understand these, you begin to see how a program behaves under different conditions, including conditions the developer didn't anticipate. Functions and modules, how programs are organized, how code is reused, how libraries extend a language's capabilities. When you understand this, you can read existing security tools and modify them for your specific needs. File handling and network sockets, reading and writing files, opening network connections. These are the building blocks of writing your own tools and, more importantly, understanding what existing tools are actually doing under the hood. Beyond Python, at some point you will encounter JavaScript because the web runs on it, and web vulnerabilities often involve JavaScript injection. You will encounter SQL because databases store the world's most valuable data, and SQL injection is one of the most prevalent and devastating vulnerabilities ever discovered. You will encounter bash scripting because the Linux terminal is your primary workspace, and being able to write shell scripts makes you dramatically more efficient. The first time I was just testing is not a legal defense. I didn't take anything is not a legal defense. The vulnerability was obvious and they should have fixed it is absolutely not a legal defense. The only thing that protects you is explicit written authorization to test the system you are testing. Full stop. So here is what ethical hacking actually looks like in practice. Bug bounty programs, the legal hunting ground. Companies like Google, Microsoft, Apple, Meta, and thousands of others operate bug bounty programs. These are formal programs where organizations explicitly invite security researchers to test specific systems under specific rules and reward them financially for valid vulnerability reports. When you operate within a bug bounty scope, you have authorization, you are protected, and you can earn real money. Practice environments, no authorization needed. Platforms like Hack the Box, Try Hack Me, Pen Tester Lab, Portswigger Web Security Academy, and Vuln Hub exist specifically for learning. They provide intentionally vulnerable systems in controlled environments. You have implicit authorization to attack these systems. That's their entire purpose. This is where you build skills legally, safely, and with structured progression. Personal lab environments. Using virtualization software like VirtualBox or VMware, you can run multiple operating systems on your own machine and build a personal lab network. You can set up intentionally vulnerable VMs, Metasploitable, DVWA, Damn Vulnerable Web Application, and others are freely available for exactly this purpose. Everything in your own lab is fully authorized because you own it. The smartest, most successful ethical hackers in the world all operate within these boundaries, not because they couldn't do otherwise, but because they understand that the legal path is also the lucrative path. A professional with a clean record, recognized certifications, and a portfolio of legitimate bug bounty findings is worth far more to any organization than someone with skills but a criminal past. The legal side of hacking is not a constraint on your potential. It is the foundation on which your entire career gets built. Protected like the asset it is. Part 9. Your first real vulnerabilities. The entry points. Now, we get into the specifics. When you're ready to start learning actual attack techniques, after you've built your foundations, these are the vulnerabilities you encounter first, and not by accident. These vulnerabilities appear on the OWASP Top 10, the most authoritative list of the most critical web application security risks. They have appeared there, in various forms, for decades. They are prolific, they are impactful, and they are deeply instructive about how web applications actually work. SQL injection, the database whisperer. SQL, Structured Language Query, is the language that databases understand. When a web application takes input from a user and incorporates it directly into a database query without proper sanitization, an attacker can inject their own SQL commands. A login form that's vulnerable to SQL injection might be bypassed with an input as simple as or 1 equals 1. The database, faithfully executing what it receives, returns all users, and the attacker is in. Understanding SQL injection requires you to understand SQL, how web applications interact with databases, and what sanitization actually means in code. Once you understand it deeply, you see why it has persisted as a vulnerability for over 25 years, despite being well documented and preventable. Cross-site scripting, injecting the browser. XSS vulnerabilities occur when an application takes user input and reflects it back in a web page without proper encoding. If an attacker can inject JavaScript into a page that other users view, that JavaScript executes in their browser with the same privileges as legitimate page scripts. This can be used to steal session cookies and thus hijack accounts, redirect users to malicious pages, perform actions on behalf of victims without their knowledge, or even take over entire user sessions. There are three main types: reflected XSS, the payload comes from the current request; stored XSS, the payload is stored in a database and served to future users, far more dangerous; and DOM-based XSS, the vulnerability exists entirely in client-side JavaScript. Each type requires different detection and exploitation techniques. Broken authentication, identity under attack. Authentication is the process of proving who you are. When it's implemented poorly, attackers can bypass it entirely, impersonate other users, or escalate their privileges. Broken authentication vulnerabilities include weak password policies that allow easily guessable credentials, session tokens that are predictable or not properly invalidated after login, missing or bypassable multi-factor authentication, and insecure password reset flows. The OWASP Top 10 has consistently ranked broken authentication among the most dangerous vulnerability categories because the impact is almost always complete account compromise. Insecure Direct Object References, IDOR. This is one of the most commonly found vulnerabilities in bug bounty programs and one of the most elegant to understand. When an application uses a user-controllable reference to access an object, like a file, database record, or user account, without verifying that the requesting user actually has permission to access that specific object, you have IDOR. Classic example: you're viewing your order history at yourorder.com/orders1234. What happens if you change 1234 to 12344? If the application returns someone else's order without checking whether you're authorized to see it, that's IDOR. Simple to test, potentially enormous impact. Server-side request forgery, SSRI. SSRI vulnerabilities allow attackers to cause a server to make HTTP requests to an unintended location, often internal services that aren't accessible from the public internet. Cloud environments are particularly vulnerable to SSRI because internal metadata endpoints like the AWS Instance Metadata Service at 169.254.169.254 can expose credentials, configuration data, and other sensitive information. Several major data breaches in recent years involving companies you've definitely heard of were initiated through SSRI vulnerabilities. These are your starting points, not because they are the only vulnerabilities that matter, but because understanding them deeply gives you a mental model for thinking about web application security that generalizes to vulnerabilities you haven't learned yet. Part 10. How Hackers Think. The Mindset Shift. We've talked about what to learn. Now let's talk about how to think. Because the technical knowledge matters, but the mindset is what separates someone who finds vulnerabilities from someone who misses them even after years of studying. A normal user approaches a system asking, "How do I use this?" A hacker approaches a system asking, "How was this built? What assumptions did the developer make? What happens when I violate those assumptions?" This is called adversarial thinking, and it is a learnable skill. Question every input. Every field that accepts user input is a potential attack surface. Every form field, every URL parameter, every HTTP header, every cookie value, anything the application accepts from the outside world could potentially contain malicious data. Ask, what does the application do with this input? Does it sanitize it? Does it validate it? Does it reflect it? Does it store it? Does it pass it to another system? Think about trust boundaries. Every system has places where it trusts data from external sources. The browser trusts data from the server trusts data from the database, the API trusts data from internal authenticated clients, the internal service trusts data from other internal services. Every trust boundary is a potential place where trust is abused. Enumerate before you attack. Professional penetration testers spend more time on reconnaissance and enumeration than actual exploitation. Understanding the target, its technologies, its attack surface, its behaviors under different conditions, makes exploitation infinitely more efficient. Don't rush to attack. Invest in understanding. Think about error cases. Developers design applications for the happy path, the way users are supposed to behave. Security researchers design tests for the unhappy path. What happens when users behave unexpectedly, maliciously, or nonsensically? What happens if I submit an empty form? What happens if I submit a negative number? What happens if I submit 10,000 characters? What happens if I submit a special character that has meaning in SQL, HTML, or shell commands? The hacker mindset is at its core a commitment to asking questions that most people don't ask. It is an adversarial curiosity, a compulsion to probe the edges of systems and see what happens there. And here is the beautiful thing. This mindset bleeds into everything else. Hackers make better programmers because they think about how their own code could be abused. They make better system architects because they think about failure modes. They make better problem solvers in general because they're comfortable exploring the unexpected. The hacker mindset is not about breaking things. It is about seeing things completely, including the parts that were never meant to be seen. Practice like a pro, the platforms that actually matter. There is one thing I cannot emphasize enough. You do not learn hacking. It's not tools. Elite hackers use the same tools as everyone else. Some of them write better custom tools, but the tools didn't make them elite. The understanding that allowed them to build useful tools is what made them elite. The tools are a byproduct. It's not luck. Some security researchers will tell you their biggest finding was a lucky accident. Almost none of them will tell you they were in a position to recognize that accident without years of accumulated knowledge. Luck favors the prepared. First, obsession with understanding. Not with results, not with recognition, not even with vulnerabilities, with understanding. Elite hackers are genuinely, intrinsically motivated by the desire to know how things work at a fundamental level. When they find a vulnerability, they're not satisfied knowing that it's vulnerable. They want to know exactly why, at what layer, under what conditions, and what that tells them about other systems of the same type. Second, patience with the process, not just with failure. Elite hackers don't just tolerate failure, they're comfortable with the entire, slow, invisible, unglamorous process of developing real expertise. They don't need every session to produce results. They trust that the work compounds, that deep understanding accumulates, that the skill builds even when it isn't visible. Third, depth of thinking over breadth of coverage. Elite hackers go deep. One target's completely understood. One vulnerability class mastered in all its variations. One technology stack known intimately. They build this depth deliberately and continuously, and they use it to find what shallow coverage misses. These are not innate qualities. They are developed ones. And the path to developing them is exactly what we've been discussing this entire video. Part 29. From hacker to creator, the multiplier. There is a level beyond finding vulnerabilities, a level most beginners don't think about yet, but that I want to plant in your mind now because knowing it exists changes how you approach the earlier stages. At some point in this journey, you stop just analyzing systems and start building them, not instead of hacking, in addition to it. Because the depth of understanding you've developed about how systems fail makes you extraordinarily good at building systems that don't. Security engineers who can think like attackers are among the most valuable people in any technology organization. They review code and find vulnerabilities during development, not after deployment. They design systems with threat models in mind. They understand the actual risks, not the theoretical ones, the actual ones, informed by real-world exploitation experience, and build defenses accordingly. Many of the best security tools in the world were built by researchers who got frustrated that the existing tools didn't meet their needs. They understood the problem deeply enough to build better solutions. Those tools are used by thousands of practitioners and have contributed to the security of systems protecting billions of people's data. The people who write the textbooks that future security researchers will learn from are researchers who developed knowledge so deep and so systematically organized that it was worth formalizing. The people who give the talks at DEF CON and Black Hat that change how the entire industry thinks about a vulnerability class are the ones who went deep enough to find something new. This is the multiplier. The same understanding that makes you a great attacker makes you a great defender, a great builder, a great teacher, a great tool developer. The foundation is singular. The applications are unlimited. Part 30. The final truth and where your journey begins. Visual, return to the cold open. The same room, the same glowing screen, the same person. But we understand now what we didn't understand at the beginning. The context has changed everything. I want to close with the most important thing I can tell you. Hacking is not about breaking things. I know that sounds strange, having spent this entire video talking about exploiting vulnerabilities, finding weaknesses, attacking systems, but stay with me. Hacking, real hacking at the level where it becomes a craft, is about understanding things at a level most people never reach. The exploitation, the penetration testing, the vulnerability research, these are the applications of that understanding. They are what makes the understanding legible, measurable, financially rewarded. But the core of it, the thing that keeps people doing this work long after the money and recognition could be found elsewhere, is the deep, genuine satisfaction of knowing how things actually work. Not how they're supposed to work, not how the documentation says they work, how they actually work. In the edge cases, under pressure, when the unexpected happens, when someone who knows what they're doing starts asking the questions that the designer never anticipated. When you reach that level of understanding, and it takes time and work and a great deal of patience with yourself, something permanent happens. You see the digital world differently. Every application becomes a system with a structure you can analyze. Every security control becomes a design decision with trade-offs you can evaluate. Every vulnerability becomes a lesson about human assumptions and the places where reality diverges from intention. The skill of hacking, fully developed, is not just technical expertise. It is a way of seeing, and once you have it, you cannot unsee. Somewhere right now, someone your age with your resources, starting from the same place you're starting from, is 3 years into this journey. They've solved hundreds of CTF challenges. They've read thousands of write-ups. They've spent nights in the terminal, frustrated and then illuminated. They've built a knowledge base that grew so quietly they didn't notice how large it had become until the day they needed it, and it was there, all of it, ready. They are not extraordinary. They made a decision, and they kept it. You can do the same. Not because I'm supposed to say that, not because this is the part of the video where motivation is expected, but because this is genuinely, measurably true. The skill we've been discussing for the last hour is learnable by you, at whatever age, with whatever background, starting from wherever you currently are. The path is clear. The resources exist. The community is accessible. The legal opportunities are real and growing. The only variable is the decision. If what you just heard resonated, if something in the last hour shifted something in you, then I want you to do something specific. Don't just subscribe. That's not enough. Open a new tab. Go to Port Swigger Web Security Academy. It is free. It is the best resource of its kind in the world. Do the first lab right now, tonight. Because the gap between watching and doing is where most people's potential dies. Don't let that happen to you. Subscribe to Audible Ecstacy because what we do here is not content. It is not entertainment. It is the kind of material that, if you let it, changes how you think, changes what you build, changes what you become. The next video goes deeper into advanced psychology, into the specific mental models that professional penetration testers carry with them, into the real case studies, the ones that made history, that changed how companies think about a vulnerability class, the ones who produced discoveries that are now textbook examples. If you're serious, you'll be there. And if you're not there yet, you'll get there. Everyone does if they stay consistent long enough. Start now.